We're all pretty used to the idea of theropods, but if there is one group that stands out as the strangest and most unique, it's Spinosaurs. Now, in recent years, this group has gotten a lot of attention and has become one of the favourites of many, including yours truly. But they have fallen to the wayside in the decades between the discovery and the loss of the Spinosaurus specimens in 1915 and the 1980s, when the world was introduced to this guy. The late 20th century was a very important time for dinosaurian paleontology, being a time when our perception of these animals shifted from slow lumbering reptiles to warm-blooded active animals with a much higher variety of lifestyles than initially thought. The diversity in life especially was noted in 1983 when amateur fossil collector William J. Walker made a finding in the Weald Clay Formation in Surrey, England. Uncovering a partial rib, finger bone and claw, he alerted the Natural History Museum of London. He then sent a team to excavate the area to see if they could find the rest. 3 years later, a new species was named from this material, Baryonyx walkeri, with the genus name meaning heavy claw, and the species honouring the man who found it. Though it was known to be closely related to the famous Spinosaurus, of which no remains had been found at the time since the holotype was destroyed in World War II, it was different enough to justify the naming of a new subfamily, the Baryonychines. As such, Baryonyx has all of the defining features of the subfamily and is a very typical member of the group. The skull of this animal was much like all other Spinosaurs, being very long and narrow for a theropod, showing more resemblance to crocodilians. The nostrils sat a little higher than usual, with the premaxilla forming what is known as a terminal rosette. This is where the end of the snout contains a concave notch, preceding a spoon-like tip that dipped downwards, and the bottom jaw being the inverse of this shape to fit in nicely. This snout was also extraordinarily sensitive, being covered in pressure sensors that could detect pressure changes in the water. This shape is very similar to those seen in modern gharials, which are used to help in catching fish. The comparison with crocs continues when we get to the teeth as well, disregarding the usual bladed morphology of other theropods and being more cone-shaped, but also being a little more recurved than other Spinosaurids. Moving up the skull, we see a secondary palate on the roof of the mouth, which is strange for a theropod, giving it the ability which we mammals take for granted, and that's being able to breathe whilst eating. Sat on top of the nasal ridge was another feature common in Spinosaurs, and that was a crest that was likely used as a display structure. Moving beyond that, we see a typical S-curved neck preceded by a body that wouldn't have stood out in shape from other theropods, if not for the slightly tall neural processes on the spinal vertebrae. Whilst it lacked a sail per se, having nothing on the neural spines of Spinosaurus, these were nonetheless present and hint that Baryonyx would have had some sort of either low ridge or fatty hump on its back. When we get to the limbs, we see legs that were ever so slightly short for a theropod, but actually pretty long for a Spinosaurid. But it's the forelimbs that gave Baryonyx its name. 3 clawed hands adorned the arms that were also relatively broad and strong for a theropod, and the characteristic heavy claw sat on the first digit. At 12 inches long, this claw wasn't only much bigger than the other 2-digit claws, but was huge relative to the body size of a theropod. This was first noted in Baryonyx, but further findings of other Spinosaurids show that this was actually a characteristic feature of the group. Overall, Baryonyx came in at between 7.5 to 10 meters or 25 to 33 feet long and around 1.2 to 2 tons in weight. But before we get into the function of this massive claw and the overall lifestyle of the animal, let's first gain a little bit of context by taking a look at the environment that Baryonyx lived in. Again, Baryonyx was found in the Weald Clay Formation, which was laid down in southern England during the early Cretaceous, between 136 to 125 million years ago. Much of northwestern Europe at the time was a series of small archipelago islands owing to the much higher sea levels, not being too dissimilar in climate to the modern Caribbean islands. Much of the land at this time consisted of either subtropical forests or fluvial/mudflats, with many of these brackish rivers leading to the Great Wealden Lake, which covered from southern England across to northern France. Living alongside Baryonyx were various arthropods, both aquatic and terrestrial, amphibians, bony and cartilaginous fish, small reptiles such as lizards, and some modest-sized crocodilians. Dinosaurs here including ankylosaurs such as the fairly recently named Vectopelta and the famous Polacanthus, along with sauropods, many of which are indeterminate or informal, but does include Chondrostiosaurus, Oplosaurus, Ornithopsis, and Euchamarotus. The most abundant dinosaur group in all of Europe during this time were the ornithopods, with a particular emphasis on iguanodontids during the early Cretaceous. This of course includes Iguanodon itself, along with Mantellosaurus, Vectidromaeus, Valdosaurus, and relatively recently named dinos like Bristonius and Compsognathus. Fellow theropods were aplenty here too, though many are also indeterminate. These include small compsognathids like Aristosuchus and Calamosaurus, decently sized dromaeosaurs such as Vectoraptor, small tyrannosaurids like Eotyrannus, and the large Carcharodontosaurid Neovenator. Most interesting here though is the relatively high number of other Spinosaurids. Here in the UK we seem to have a much better supply of Spinosaurids, with the exception of Spinosaurus itself, with the group being abundant overall here, in Northern Africa and Spain. In this case, on top of Baryonyx, we also have Ceratoseucops and Ripperovenator, both of which were named in the same paper in 2021 and were similar in size and morphology to Baryonyx. Now anytime something like this comes up, I always ask myself, how did they coexist without outcompeting each other? This kind of question runs even more true when we're talking about such large carnivores given their high caloric demands. Now these two were found in rocks stratigraphically younger than many other Baryonyx specimens, so it's possible that they didn't meet, but there still could have been some overlap. Before we get to how this might work though, we should first take a look at what kind of life Baryonyx actually had. Baryonyx showed its typical nature as a Spinosaurid, being a primary pescivore. With its elongated snout, cone-like teeth, high nostrils and premaxillary sensory depressions, it was primed for resting that long face in water, waiting for unsuspecting fish to come on by. Those characteristic claws would have also been essential in this endeavour, using them in a similar manner to modern grizzly bears to gaff its prey out of the water. Now the relatively long neck would have come in handy for this, but arguments were made that this neck was the primary sign of a scavenging animal. Andrew Kitchener argued that the jaws and teeth were too weak for other dinosaurs, but also too heavy and slow for piscivory. Now many people hold a very bold line between predation and scavenging. The reality is that it's more of a sliding scale. Now whilst Baryonyx probably wasn't above picking at a free meal, most people, including myself, can't get over how many piscivorous adaptations that Baryonyx had. Sure, Baryonyx had very long legs for such an aquatic feeder, and probably wasn't the best example to look at when it comes to an animal built for a semi-aquatic lifestyle. But neither are bears, and they seem to do piscivorous predation just fine. The grizzly bear example is likely the best analogy for Baryonyx that we have, being a capable terrestrial carnivore whose preference might be fish, but whose success comes down to its adaptability for other sources of meat when the need arises. But the next question brings us back to Baryonyx's relatives, and that is, how many variations of this lifestyle existed so that these animals could coexist together? This question comes up all the time with Mesozoic predators, so Baryonyx is a great example of showing just how alien this world was. Theropods that are closely related and/or are very morphologically similar seem to exist in many of the same environments at the same time. Given the high ecological demands of a carnivore of such sizes, how are we seeing such a different ratio to today's natural environments? We know that Ripperovenator and Ceratoseucops existed together, and that there was a possible overlap with Baryonyx. Now granted, if there wasn't an overlap, it could mean that these two were derivatives that Baryonyx evolved into, but the question still remains. Well, paleontologists threw out some ideas, stating that niche partitioning could be down to more than just the animal's morphology. For example, they could have been separated by time slots, whether that be that they rotate seasonally or have differing circadian rhythms. Or they could have simply respected each other's own territories. Or maybe Ripperovenator and Ceratoseucops simply did what Baryonyx did, but better, pushing this dinosaur into obscurity and eventually extinction. Whilst you ponder that, I'm going to answer today's questions, which is on a laptop because the printer's on the blink. The first of which comes from Gavin Lafferty 9803, who has asked, I've always adored paleontology and have learned everything I can about the field of science. One thing in particular about phylogeny had me thinking about how many animals diverged from extant groups that we have today, from both synapsids and diapsids. Work on a speculative biology projects have made me wonder, is it possible that there was an intermediary third clade, one that wasn't entirely synapsid or a diapsid, but either somewhere in between or its own unique group that evolved from a common amniote ancestor? Okay, so for those that don't know, you've got two main clades of amniotes. You've got the synapsids with just one temporal fenestra, whose only living relatives alive today are the mammals. And then you've got the sauropsids, which is kind of where it gets messy already, because diapsids are within sauropsids along with anapsids. Sauropsids are, for all intents and purposes, the reptiles. Now, diapsids, with their 2 temporal fenestrae, make up most of this group and include all of your dinosaurs, crocodilians, lizards, etc. But then you get the odd anapsid with no temporal fenestra, such as the weirdo turtles. Now, it's not fully agreed upon whether or not turtles were diapsids whose fenestrae closed up, or if they split from the rest of reptilia long before. A third option is that they are part of yet another group known as euryapsid, which are extinct, though potentially excluding turtles, reptiles that are thought to have started off diapsid but have only 1 temporal fenestra left. But they do differ from synapsids because they kept the upper fenestra and not the larger lower one. So as you can tell, the whole topic is quite messy and has a lot more nuance than we first initially thought of fitting these all into really neat little categories. In short, yes, it is absolutely possible that several clades existed in between, or even split off before synapsids and diapsids were fully distinguished, since we have plenty of animals that fall outside of those parameters. We just can't figure out if they are derivative or fall outside of either group. And our second question comes from StimTheo6077, who has asked, there are speculations about Megaraptorians and Tyrannosaurids being sister groups. What is your opinion on that? Yeah, so the original idea was that Megaraptorids were actually carnosaurs, which are basically your more reptile-like theropods like Allosaurus, Carnotaurus, Giganotosaurus, etc. But now they're considered Coelurosaurs, which are your more bird-like theropods like Dromaeosaurs, Tyrannosaurs, Compsognathids, birds, those guys. By the way, I know that how I've just distinguished them can be picked apart for hours by all you other paleo nerds, but it'll do to get our head around the gist of the concept. Anyway, Megaraptorids have been placed within Tyrannosauroids, which essentially means that they're really close to being true Tyrannosaurids, but fell just outside of that family. I think it's becoming more and more obvious that they are Coelurosaurs, with the slightly more bird-like hips, and the femur being shorter than the shin bones. And if you're going to place them within Coelurosaurs, then a glance at them will tell you that the family they are most like when compared to others in this group is the Tyrannosaurids. Now, I've never closely studied either group, so my opinion on the matter doesn't carry as much weighting as the Tyrannosauroid experts, but I am inclined to agree with them, purely because there are so many features of Megaraptorids that are shared with Tyrannosaurids that for some reason were initially written off as convergent. As the sample size grows, however, more and more evidence seems to be coming to light about how closely related these two groups actually were. Thank you for submitting those. I hope you enjoyed the answer for them as much as you've enjoyed the video. And if you have a question that you want me to answer, be sure to keep an eye out for the next community post where I'm collecting all of the questions, which is going to be dropping any day now. Until it does so, I will catch you guys next time.